This one's not too bad. Part B is a little harder, but for this one, I think we could all figure out like what's 50%. Like 50% as a concept is what? That's half. So I kind of started there and I said, okay, well, 50% of 180, half of 180 would be what? 90. Okay, and then you could also say, okay, well, what's 10%? 10% would be like a tenth, or it'd be like 10 cents of a dollar or something like that, right? So I could say 10% of 180 would be what? 18. Right? And so when I add these two together, I get my 60%, no problem, which means I can add this over here. So I get 108, which means 60% of 180 is 108. Now I think some of you are probably doing what in your calculators? 0.6 times 180, and that should come out to be 108. I think one of the struggles that I'm having with this particular course is trying to give you all the options of how to do this without a calculator. That's not easy. In fear of you not being able to do it in like a grade 11 IB exam. Okay, that's what's stressing me out right now. Just trying to do all this stuff, and I've already told you my mental math's not great. That's like something I have to work on, right? But I don't have to write an IB exam, so joke's on you. So anyway, I try my best to figure this out for you, but sometimes it doesn't go well. Right? That's where you guys catch me in errors. For this one, I tried doing this without a calculator. It's kind of hard to arrive at the answer by using the same approach. Kind of hard because it's, if any of you have typed it in the calculator by now, it kind of comes out to a decimal, which is hard to get to. But the way you would do this is like, okay, well, if I want, remember we can't deal with percentages. Percentages are just relative to like 100, right? So if I divide the 80% by 100, I'm going to get 0.8, right? But I want it to equal 25. And so what I'm going to do is set like kind of a an X there, like the placeholder. That's what I'm trying to solve for, is what is the number? What number times 80% or 0.8 of what number? That's what this literally says. 0.8 of what number equals 25. That's what that statement says. Okay, and the what number is the X piece. We're using it as a placeholder. Okay, has anybody ever done any solving? Have we done solving yet at any point in our math careers? Like something is, not that this is simple, but straightforward. How are these two things? We're going to do this in this course in more detail in case this doesn't make any sense. But you could trial and error it. That's going to take a bit of time. How are these two things attached? Presently. Do you see any addition, subtraction, or anything? These two things here I'm talking about, sorry. Sometimes I'm not specific. Yeah. Okay, so they're attached with multiplication. Okay, and then what's the opposite of multiplying? Dividing. So if you're multiplying on the left and you want to untie that multiplication, you can divide on the left. But you can't just do it on one side and not the other, because now you've changed things. Right? So to get it by itself, or like to solve, you got to divide both sides by 0.8. It's at that point nothing has changed because you've done it to both sides. Okay? You've added the same, or like be like a balance, right? If you like did something to one side of the scale of the balance, then it would go out of whack. But if you did the same thing to both sides, then it would stay in balance. So that's what this is, okay? Just dividing both sides by 0.8. And then we've already learned, again, this is Mr. Poland being good at what he does. We've done all these lessons in order here. What's 0.8 divided by 0.8? We've seen this a number of times already, right? It's just 1. right? So now you get 1x. Do we need to write the 1? 1 times anything is what? Anything, right? So we just get x. X equals, and now you can type that in your calculator. 25 divided by 0.8. What's that number? This would be an okay one to type in your calculator. This is not an easy one. I tried doing this without a calculator. It was too hard. $31.25. Okay, that means 31.25. Sorry, 25 is 80% of 31.25. Okay, that's the missing number. There's all sorts of different ways. Mr. Poling has this done a different way than I did earlier as well. Okay, I'm gonna do like one approach, and then I show you two approaches. It doesn't matter, but the one I was kind of looking at. So normally, like this fidget spinner costs $15, right? What I tried doing earlier. What's 50% of 15? Same approach as number one. So let's say you were doing this in your head, right? Or like on paper without a calculator. 50% of 15 is what? 7.5, right? Okay, so we're at, so in relation to dollars and cents, 7.5 would be $7.50. We're pretty close to the $8, but not there. Okay, what about, what's 10%? Is that going to be too much? 10% of 15, what's that? Be 1.5. So I'm not going to add $1.50 to this, right? But I could go, okay, well, let's cut that in half. What's half of $1? So if I cut 10% in half, I get 5%. What's 5% of 15? Or if you're not happy with that, what's like half of 1.5? What's that? Because I half the percentages here. So what's half of 1.5? If you had $1.50 in your hands, and what's half of it? Yeah, 0.75. Okay. So this is a relatively new approach for me doing this today. Instead of like going right into the calculator and doing this. So you can kind of like piece it together, right? That's obviously, you can't add 0.75 either because you're going to shoot over the $8, right? But what about 1%? 1% of 15 be 0.15, right? So if I took the 750, this gets you pretty close. It's not the exact answer, but it's pretty close, right? So if I go like 50% for sure, and then how many 1%? So like, look at here. If you want to get the $8, what combination of like what I've circled here in asterisk will get you to $8? I would say one of these, or pretty close anyway, one of these and 3 of these, I'd say. Would everybody agree? So if I added up like 7.5 plus 0.15 plus 0.15 plus 0.15, right? You could see that adds up to be 795, which is pretty close. Okay, this is just kind of one of the downfalls of like, if you were ever given this question on like, let's say EQAL or something, and or IB or whatever, right? And you weren't allowed to use a calculator, you would get pretty close. It would probably be a multiple choice question, and you'd say A, B, C, D, or E, right? You'd get the one that's pretty close, right? So that means, did that answer the actual question? No, we didn't actually just say like what the percentage discount was. Well, it would be 50 plus 1 plus 1 plus 1, so 53% discount-ish. And if you actually did it in the calculator, you would find out that it's 53.3% to be exact. But how many times do you walk into a store and see something 53.3% discount? Not too often. They'll mark it down 40%, 50%, 55%, whatever it is. Okay? Was that too much for anybody? It's kind of interesting. I thought that was cool today, being able to do some of this stuff in my head. Right? Okay, if you wanted to do the next question, you could go, okay, well, you could do the same thing, but if you wanted to do the, if you wanted to use your calculator, which is probably what most people would do walking around a store or something, they pull out their phone and figure out what's the percent discount, or what's the shirt going to cost me here, right? So to figure out what the actual dollar amount is here, if something is 40% off, what percentage are you going to actually pay of the original price? So if you have 100, like let's say you're going to pay 100% originally, and then the thing goes 40% off, what's the percentage that you're actually going to pay? 60%. Now, do we work with percentages? Don't work with percentages, right? We work with decimals. So the actual, like if you were doing this in the store or something like that, you'd go 0.6. You'd multiply 0.6 times whatever the price of the item was. Okay. What is 0.6 of 50? Yeah?
0.3. Well, 30.
30.
Yeah.
Okay, so 0.6 times 50 would be 30, right? Which would be $30. That's what you're actually going to pay for the item, right? When it's 40% off, okay? Now, this question specified you got to include the tax. Okay, what is tax? What's the percentage for tax? Does anybody know? Yes, Holly? 13%. So you could do this one of two ways. You could, again, throw this into your calculator, and, well, there's two ways. You could multiply by 0.13 and then add the original price, or you could be a little bit smarter about it and multiply by 1.13. Or, if you didn't have a calculator, for instance, we could dissect this again. 10% of 30 would equal 3, right? And then you could go, okay, well, 1% of 30 would equal 0.3. And then you go, okay, well, if I need 13%, that means I'm going to need 3 of these and 1 of these. Right? And so you could go, okay, well, I'm going to take my original item, the $30, and then I'm going to add in the tax pieces. So plus 10%, plus 1%, plus 1%, plus 1%. There's your 3% and your 10% tax, right? And so we just figured out what the dollar amounts were. Your original item plus 3 plus 0.3 plus 0.3 plus 0.3. These will both give you $33.90. Questions, comments, or concerns? How many of you done like ratio work in elementary school? A bunch of this. Big thing is like ratio work is like when I'm working on my bathroom and mixing concrete, they want a particular ratio of concrete to water. So you got to pay attention to it. You know, if you wanted like X number of, I figured out that because of the tile that I'm using, I figured that it's about approximately like 9 pounds of concrete did one tile. I'm using big tiles. So then I'm figuring out like in my head, like, you know, what's the ratio of water to concrete, so to give me that 9 pounds per tile sort of thing, right? So that's where I've used ratios in my recent life, okay? So if we go down here, okay, iced tea is made by mixing 2 cans of concentrate and 3 cans of water, okay? What is the ratio of water to concentrate to iced tea, okay? This, if everybody gets here, and then we can talk about it, okay? I wasn't sure if everybody was done copying or not. Okay, so here's the way ratios are gonna, does anybody know what the answer is off the top of their head? Just by looking at this? This tripped me up today. It's kind of annoying, actually. So obviously, like when we mix stuff together, we're gonna have like 2 to 3, right? But then how much is in total? Like for you to actually make whatever it is, the iced tea, how many parts are there in total? You had 2 parts concentrate and 3 parts water, so how many are there in total? 5, right? So 5. So you're gonna have something that looks like this. 2 to 3 to 5 in total, okay? Okay, and that's all we're looking for. And you can keep track of, like, I suppose if you wanted to, you could keep track of, like, concentrate, water, and total. Okay? Okay. Does anybody have any questions? So Sally is making a drink that is a mix of crystals and water in a ratio of 3 to 7. Okay. She starts by mixing 15 cups of crystals with 9 cups of water. Okay. How many more cups of water should she add to have the 3 to 7 ratio? I think I'm going to try and do this just maybe again, try to do this a different way to represent different representation of this question. When we write ratios on a page, when I've done this in the past, what's another way to write a ratio? I think there's 3 ways to write a ratio. What do you got? Different ways. Well, this is one of them, obviously. But if you just had 2 pieces, 2 components, right? You could always write a ratio, something like, for instance, this 3:7. What is a ratio? Or you might even heard the word like a rational. Ratio, rational. Kenneth, what do you got?
Can't you also write as a fraction?
You can write as a fraction as well, right? So you could say, okay, 3, like a ratio of 3 to 7, you can write like this as well. And this conventionally is the way that I kind of like to do it, right? And the reason why, let me spell this out. This is the way I like doing ratio questions, like proportional reasoning. We're going to do a bunch of this too in here, okay? 3/7. 3 represents what? Yes, Colson?
3 represents a proportion of crystals.
Sure. Okay, so we're going to get like crystals. And obviously then on the bottom we're going to have water, right? And so if I came over here, the rest of the way, she starts by mixing 15 cups of crystals. Where did you put crystals on in your fraction already, or your ratio? It's in the top or is it in the bottom? Numerator or denominator? Yeah, it's in the numerator. So don't mix. So just say, okay, well, if she starts by mixing 15 cups of crystals, then put it on the top where the crystals went on the other ratio. And what is it asking to solve for? Well, it's asking to solve for, like under these circumstances, how much water is needed. So you could call that X or whatever you want. X amount of water. Have we ever done anything like this before? Do we know what the next step is? We got this fancy little process that doesn't go away. Kids don't like it, but it don't go away. I don't really know why kids don't like it. They just don't like it. Yeah.
Can you multiply the denominator by the numerator?
Yeah. On both of them, right? So we call this cross multiplication. Has everybody ever heard this before? Okay, so we cross multiply across an equal sign. And when we cross multiply, we rewrite that line, right? And I'm purposely writing the units here so that everybody sees what happens, right? So I'm going to get X amount of water multiplied by 3 crystals. And that has to equal 7 waters times 5 crystals. Okay, what if I wanted X by itself, which is ultimately what you want. If you want X by itself, I'll let you guys get caught up here. So I see some of you writing. Yes, Cole?
Is it 7 waters by 5 crystals? Because you wrote down 15.
I put in brackets. Oh, in the top? Sorry. I see what you said. Okay, thank you. Okay, how do I get, if I'm interested in this is obviously the answer, right? We don't know what the answer is, but that's what we're interested in. It's a placeholder. Okay, so if I want to get that by itself, again, I'm looking at how things are attached to one another on the left side. And how are they attached to one another? Aaron? Multiplication. So if I want to get something by itself, I'm going to do the opposite of what I see on the left. Right? So if I see that they're attached with multiplication, I'm going to divide by 3 crystals on both sides. Okay, and quite often, I'm sure along your schooling career, people have said, make sure you write units, and I'm sure you've gotten sick and tired of it, as I was hearing it all the times I did in school. But one thing that never got conveyed to me until I got to university was like this idea of like dimensional analysis, which is a fancy word of saying just like fancy way of saying like units will like kind of tell a story, and like your units have to work out on left side and right side. That's all it means. So this, you follow the units through, and the reason why I've included the units here, you'll see in a sec. Much like what we've been doing today, when we have like whenever we've seen like 4 in the numerator and 4 in the denominator, we were able to cancel them out. Does everybody agree? Didn't matter what the numbers were. Well, the same goes for units. So this question is asking about how much water is needed. Does everybody agree? And so I better expect to see, when I do all of my math, I better expect to see that the units just come out to be water. Okay, and what dimensional analysis will do for you as you move through the sciences and whatnot, it keeps track of the units. Okay? This is a very simplified version of like dimensional analysis. Not really a dimension because we're talking about water and crystals, but we're following the units around. Right? So let's look. Oh, look. I have crystals in the numerator and crystals in the denominator. And there's no addition subtraction signs. Does everybody agree? So what could you do? It's no different than a number. What could you do? What's crystal divided by crystal? Do we need to revisit what 4 divided by 4 is? It's just 1. Crystals cancel with crystals. What's the unit left there? Now you're not canceling the numbers, just the words, right? Okay, you're still going to run through the rest of the math. But all that's left is, in terms of units, is waters. Well, that's what you're after. So now you can go, okay, well, 7 times 15 divided by 3. Oh, do we have a little trick here? What is 15 divided by 3?
5.
5. So it's 7 times 5. I think we all know what 7 times 5 is. 75. What do we get? Did I hear 75? 35. Okay. Thought I heard 75. Okay. Is that how much water we actually need for this? Are we almost done? Almost done, but not quite. What time we got? Oh, we're close. Is that how much we need? That's what needs to be there in total, but how much has already been put in the question? Yeah. 9. So what's left is we need to take what like is in total in order for this ratio to work out. That's what the 35 waters is. But we've already put in 9. Okay, so what's needed to make this ratio nice and balanced? So you have this nice, I don't know if it's iced tea or lemonade or whatever. We want a nice lemon flavor, right? We'd have to say, okay, we got to take off the 9 we already put in, which is 26. So therefore you need 26. Can we see? Okay, yeah, 26